Hey everyone, today I'm super excited to show you how to train your very own LoRA model that's super similar to real life characters. Imagine putting your favorite characters into any scene with amazing consistency. Pretty cool, huh? Alright, check this out. Here's an image I created with a LoRA model I trained for, the incredible Scarlett Johansson. Looks pretty good, right? So, you're probably wondering, how do we get started with training a LoRA? Back in the day, it was all about coding. Long, complicated strings of it. Only the real techie folks could handle it. But then some genius developers came up with user-friendly graphical interfaces, making our lives a whole lot easier. One of the best tools out there, loved by folks everywhere, is called Koya. It's not just for LoRA, you can use it for Dream Booth and text inversion too. And setting it up, piece of cake. Just head over to Koya's GitHub page, and you'll find all the instructions you need. Once you've got Koya ready to roll, the training process kicks off. It's pretty similar to text inversion, which I covered in my last video. Here's the breakdown. Number 1, prep your dataset with the images you want to train on. Number 2, get those images ready, crop them and add captions. Yeah, you heard that right, captions. Number 3, dial in the training parameters in Koya. Number 4, hit start and watch the magic happen in your command line. Number 5, test out the results and pick the best LoRA file. Sounds a bit complex? I get it. This might sound a bit like we're diving into the deep end of the pool here. You might be scratching your head wondering, why all this talk about captioning, and what's with this training method? No worries, let me break it down for you in simpler terms so it all clicks. Let's look at this diagram. Imagine we're trying to teach a computer to recognize and recreate a face. Say, we're working with a photo. Our end goal? We want this smart computer, our LoRA model, to spit out a new image that looks super similar to the original photo we gave it. But how do we get there? Let's unpack it step by step. Think of the LoRA file like a little add-on or a booster pack to something called the diffusion model, which is the brain behind the operation. During training, this booster pack tweaks its settings, or weights little by little, aiming to get a result that's super close to our original picture. Here's how the magic happens. First, some initial noise is added to the training image. The noisy images are later used for comparison. At the same time, noise is added to the training image in this direction. It is similar to the image-to-image process in Automatic 1111. After the noise is added, the diffusion model denoises the training image based on the caption we made for it, such as one girl here. This is why we are captioning the training image before training. After denoising, a second image for comparison is generated. After comparing this image with the previously denoised image, a loss value is calculated. This value is like a score that tells us how far off we are from the original. Then the AI will use this score to fine-tune the additional weights of the diffusion model so that the next image denoised by the diffusion model is more similar to the original training image. This process is iterative. The adjusted weights, or the training effect of the LoRA file, will be better and better. There is an important concept here, which is training steps, because we need to set this value in the Koya trainer. This number of steps is the number of iterations. But wait, there's more. We don't just train on one photo, we do it many times with the same photo to really hammer it in. This repetition is what we call repeats. After we've gone through a set number of repeats with all our photos, that's considered one epoch, a complete training cycle. And yep, you guessed it, we can do multiple epochs to really refine the model. And this parameter is also present in the Koya trainer. Alright, now that we've got a good grip on how LoRA training works, let's dive into the fun part. Training with Scarlett Johansson as our star. It's go time! First things first, we've got to prep our dataset. This step is super important because it lays the foundation for everything else. Think of it as gathering the best ingredients before you start cooking. Here I summarize some requirements of the dataset. You can refer to it. Once we've got our images, we move on to pre-processing, which involves cropping and captioning. This step ensures that Scarlett's face is perfectly prepared for the spotlight. We'll crop the images to focus on her face and a bit of the shoulders, keeping everything at a 1:1 aspect ratio. This helps the AI really get to know her features, so when it's game time, the images it generates are spot on. And don't worry if we're only working with headshots, we can always mix and match with full body shots later for some cool face swapping action. That's how I generated these Scarlett Johansson images. There's a lot of flexibility to get whatever style you want. Now let's talk about upscaling. Most pics online aren't super high res, especially after you've cropped them down to just the face. So we aim for a resolution of at least 512 by 512, or go big with 768 by 768 if your computer can handle it. Why? Because upscaling brings out all those tiny details, making our AI's job of learning a whole lot easier. And the result? Super detailed images that look incredibly real. For the upscaling magic, I'm all about using Topaz software. It's a game changer. But hey, the stable SR script in Automatic 1111 isn't too shabby either. I've put them head to head and Topaz still comes out on top. After we've upscaled and enhanced those details, we do one last crop to perfect the shot. If you missed my last video where I talk about this awesome online cropping tool, definitely check it out. It's a lifesaver. And don't worry about missing out. I'll drop the links to both the video and the cropping tool in the description below. Trust me, you're going to want to have these tools in your arsenal. Alright, moving on to the next big step. Captioning. I've already touched on why we add captions to our images in the section on the underlying principles of LoRA training. And if you're not sure how to captioning, you can always take a peek at my last video where I dive deep into the nitty-gritty of captioning. And there's a link in the video description that'll zap you right to the spot you need. After our image is prepped and ready, we dive into setting things up in the Koya trainer. This is where all the magic settings are. There are many tabs here. Let's choose LoRA. The first setting option, pre-trained model name or path, is to set the base model used for training. The concept of base model has already been mentioned in the introduction of LoRA training principle. The base model is the diffusion model in this case. LoRA is based on the base model and adds some things to it by fine-tuning the weights to affect the output of the base model. Now, I've got a hot tip for you. The basic SD 1.5 first generation model. This baby has proven itself in my tests, outshining even the fancier SDXL model. Trust me, you'll want to check it out. I'll drop the download link right below the video so you can easily grab it and get started. When you're setting up in Koya, you'll have the option to either choose a model name or directly input the path to where you've stored the base model on your computer. I strongly suggest going with the path. It's straight to the point and avoids any confusion. Below that option, you'll see a few more checkboxes, but let's not complicate things. Leave them unchecked and keep moving forward. Next up, we've got the trained model output name field. This is where you get to be a bit creative and name your trained LoRA file. Think of it as naming your masterpiece. Looking to the right, there's more setup to do. We need to specify the image folder, and beneath that, there's a button that reveals even more paths we need to set. This one is for the output folder of the LoRA file, and this regularization folder should be left alone. Some tutorials may teach you to use regularization images, but this method is not suitable for training faces or other anime characters. Instead, it is better suited for training styles. Here you need to set the path to the folder where the training logs will be generated. Before you dive into filling out these paths, you've got a bit of homework to do. Create a new training project folder. Let's say you name it Scarlett Johansson because, well, Scarlett Johansson. Inside this folder, you'll need to make 3 more folders. One for images, one for models, and one for logs. Alright, we're moving on to a crucial part of setting up our project, organizing the image folder. You're going to need a special folder here to keep your dataset and captioning files neat and tidy. Let's say we name our folder 25_Scarlett Johansson. This naming style is pretty important. The number 25 inches is all about repeats. Basically, it's telling us how many times each image gets used in the training set. Remember how we talked about repeats earlier? If you need a refresher on that, now's a good time to loop back. Generally, you'll want to keep this number somewhere between 10 and 30. The part after the number, that's your concept, like a specific outfit, or in this case, the name of the character you're focusing on, like Scarlett Johansson. You can even dive into training multiple concepts by setting up different folders for various training sets. Once you've got your dataset sorted into this folder, head to the top of your file browser, copy the folder's path, and then paste it right into the Koya trainer setup. But here's a little heads up. Make sure you're copying the path that leads just to the image folder, not directly into the 25_Scarlett Johansson or any specific concept folder. This little detail makes sure Koya knows exactly where to look for all your training goodies. Alright, now that we've got our folders and paths all set up, we're stepping into the zone where things get a bit techy but super interesting. The parameter settings. This part might seem like a maze with all its twists and turns, but don't stress. I've got you covered and we'll walk through it together. First off, we're going to pick our LoRA type. There are a number of options in the drop-down list. For training faces, stick with the standard option. It's your solid go-to choice. Planning on diving into the world of anime characters? There are options tailored just for that. But for now, let's keep our focus on the standard setting. Next up, we've got train batch size. This is all about how many images AI tries to learn from at one go. If you're working with a beast of a computer that's got lots of video memory, you might be tempted to crank this number up. But here's the catch. Bumping up this number means you also need to adjust the learning rate, and that can get a bit complicated. I will explain the concept of learning rate later. To keep things simple and smooth, I usually stick with setting it to 1. The epoch and max train steps on the right side have already been mentioned in the part of the introduction of LoRA training principle. How to set these parameters? Let's break down this formula to set up our training session like pros. It might look like a bit of math homework, but it's pretty straightforward once we dive in. The formula to figure out max train steps goes like this. It's the number of images you have multiplied by repeats and then multiplied by epoch, all divided by the train batch size. Since we're keeping the train batch size at a cozy one, it's not going to change our calculations much. It's like the quiet friend who's just along for the ride. Now, the number of images is what you've got in your data set. That's set in stone for now. The variables we get to play with are max train steps, repeats, and epoch. I usually start with max train steps, then epoch, and finally repeats. For max train steps, setting it between 3,000 to 5,000 steps gives us a good stretch of road to cover, ensuring our model learns well but doesn't get too tired or overfit. Epoch. This is how many complete rounds we'll take on our trip, with 5, 10 being the sweet spot. In Koya Trainer, to control how many LoRA files we're bringing home, we use save every n epochs. Setting it to 1 means we get a LoRA after every epoch. If we're doing 10 rounds, epoch set to 10, we'll end up with 10 LoRA files. We can compare LoRA training to baking bread. If epoch is set too high, it will cause overfitting. That is to say, the bread will be burnt. But it's okay to set it higher because we have 10 versions. If the 10th version is overfitted, then maybe the previous version is not overfitted. If epoch is set too low, there are fewer versions to choose from. So I think 5, 10 is a good range. Once the range is set, let's finalize the values in order. If we decide on max train steps of 4,800, have 32 images, and set epoch to 10, we can figure out our repeats by dividing 4,800 by 32 and then by 10, landing us at 15. This means each image gets revisited 15 times per round. Then we go back and rename the dataset folder. Jumping back into the Koya Trainer, we're setting epoch to 10 and leaving those other two options right next to it untouched. For save every n epochs, we'll stick with 1, meaning we're snagging a snapshot of our progress at every single round. The caption extension should be .txt, a tiny detail but super crucial for making sure your captions are recognized. If you ever hit a snag with a no caption file found error, it's likely because this little guy was overlooked. For the precision options below, go for FP16. It's like choosing the right gear for a smooth ride. Let's look at the cache latence on the right. Turning this on is a game changer. It stores all your images in memory right from the get-go, making everything run faster since it doesn't have to keep fetching them. The following area of the parameter settings, I recommend 2 sets of programs. Before introducing my programs, let's first understand the meaning of each parameter option. There is a very important concept here is learning rate. These parameters are related to it. Learning rate is literally easy to understand. It is the strength of the AI to learn the images in your training set. If you compare the process of training LoRA to baking bread, learning rate is the temperature you set in the oven. The higher the temperature, the faster the bread bakes, but it is easy to burn the bread. This is also known as overfitting in machine learning. The lower the temperature, the slower the bread bakes. A long time may pass and it is still not toasted. This situation is called underfitting. You can adjust the learning rate on the fly with something called the learning rate scheduler. Below is the additional parameters it can add. Another important concept closely related to learning rate is optimizer. As mentioned in the LoRA principles section, the training process is iterative and the AI will update the additional weights based on the loss value, and the optimizer controls how the weights are updated. Here are the additional parameters it can add. Some settings like learning rate warm-up, you can just skip. Set it to 0 and move on. LR number of cycles, we'll circle back to that. Don't sweat the learning rate power either. Now, max resolution is crucial. If your image is a different size than the default, I've got mine set for 768 by 768, but adjust as needed for your images. Let's talk about enable buckets. In a nutshell, you don't want to mix and match image sizes during training. Koya can sort images into buckets by size, but honestly, it's best to pre-crop your images to the same size. I recommend not enabling this option to keep things simpler and quality higher. The learning rate settings for text encoder and UNet are next on the list, but the real MVP here is network rank. Remember the meaning of LoRA in the LoRA underlying principle diagram. This network rank parameter regulates the number of neurons in the hidden layer of the neural network in the additional weights. The more neurons there are, the more learning information can be stored. In other words, the larger the parameter is, the more detailed the trained face will be. More neurons mean more details, but don't go overboard or your models might end up looking weird and file sizes balloon. This parameter on the right is more complicated to explain. I will introduce how to set it later. Okay, I've finished explaining the basic parameters. Now let's talk about fine-tuning your setup with my to-go-to programs. Starting with program 1, I always go with Adam W 8-bit for the optimizer. It's like the trusty old hammer in your toolbox, not the fanciest, but it gets the job done right every time. For the learning rate scheduler, pick Cozine with restarts. It's like giving your learning rate a rhythm, peaking and dipping in a way that covers more ground. You'll want to set the LR number of cycles to somewhere between 3 and 5 to hit those peaks just right. Learning rate is just kept as default. The learning rate warm-up is set to 0. When tweaking the learning rate for the text encoder and UNet, the recommended settings are 0.00005 and 0.0001 respectively. These are straight from the Koya playbook, so you know they're solid. The network rank is a big deal because it decides how much detail your AI can learn. Setting it to 128 works for me, but if you're into anime characters, try 64 instead. The network alpha should be half of your network rank or less. Don't worry about the rest for now. After setting up the basics, let's peek at the advanced settings. There's this one key feature, cross attention, you'll want to turn on. Flipping the switch on X-formers here is a game changer, cutting down on memory use and speeding up your training big time. Alrighty, we've got the first program set up out of the way, so let's dive into the second one. This time around, we're looking at a different approach for the optimizer. If your computer's got the muscle for it, go for DAdaptAdam. This one's a bit of a memory hog, needing at least 6 GB of video memory to run smoothly. But hey, if you're running low on that sweet RAM, no worries. There's another optimizer called Adafactor that's more forgiving on your system. These two optimizers are pretty clever, automatically adjusting the learning rate to keep things balanced and help avoid overcooking your training, aka overfitting. Now, if you decide to roll with DAdaptAdam, you'll need to add this specific line to the additional parameters section. And it's the same deal if you choose Adafactor. Just pop a different line in there instead. Since both these optimizers are smart cookies and adjust the learning rate on the fly, you'll want to set all 3 learning rate options to 1. Keep everything else the same as we laid out in the first program. Once you've got all your settings dialed in, it's go time. Hit that start training button and let the magic happen. Now, as the training kicks off, we'll need to jump over to the terminal. That's the command line window we fired up when we got started with the Koya trainer. Since I'm running Koya on a server, what you see might look a bit different from what's on your screen. Once we start the training, we can immediately see all the parameters we've just set popping up on the screen. It even does the math for us, calculating the total number of training steps we're going to take. We've aimed for 10 epochs, and now we're cruising through the first one. As long as we see that progress bar making its journey across the screen without any hiccups or error messages popping up, we're golden. This means our training session is running smoothly just as planned. Keep an eye on the right side of the progress bar. It gives an estimate of how much time we've got left. Another key thing to watch is the loss value showing up at the command line's end. This number is super important. It's how we gauge how well the training's going based on what I explained about the LoRA principles earlier. Let's skip ahead a bit. And there we have it, training's wrapped up. When you see model saved pop up in the command line, it means your LoRA model is good to go. All right, now it's time to dive into the results. In our output folder, we've got 10 LoRA files waiting for us, so how do we figure out which one nailed it? The best way is to test them out directly and see which one brings the magic. For our test run, let's pick the last LoRA file we generated and rename it. Then we're going to move all these LoRA files over to the folder we usually use in Automatic 1111 to work with LoRA. Got them all copied? Great, let's jump into Automatic 1111. Here's the game plan. We'll write our prompt and adjust the basic settings. Then we're going to bring in LoRA #1, the star of our show. Scroll down to the bottom of the script and pick XYZ plot for a bit of visual action. For the X type, we go with prompt search replace, and in the X value, plug in the number of the trained LoRA. This setup will line up the result images of our LoRA files nicely on the x-axis. For the y-axis, it's the same deal. Choose prompt search replace and fill in those y values with different LoRA weights. This way, we get a visual on how each LoRA file performs across various weights. Once these values are set, we scroll up and click the Generate button. The plot will spread out before us, showing the performance of each LoRA file horizontally. We're looking for the one that looks most like our character with the crispest image quality. Vertically, we'll see how the weights affect each LoRA's performance. And that's a wrap for this video. If you found it useful, don't be shy to hit those like and subscribe buttons. Your support means a lot. Thanks for hanging out, and I can't wait to see what you create with your own LoRA training.